Welcome to VINDAL'S concept. This time, I'm going to be introducing you to Waec experiment on electricity, which is the conventional number 3 question that usually comes out in every Waec. This year is 2021 Waec practical. I'm going to be making sure that the experiment is well understood by you, being able to take your precaution, plot your graph, and answer the theoretical questions that will be coming. And I'm going to be promising you that you're going to make a whopping 25 marks in this electricity. And remember, if electricity is the most difficult part of your physics learning, I am going to be erasing that from your memory. And also, if this is your first time of coming to this video, to this channel, please don't forget to share, like, subscribe. And if there is anything that is confusing on the process of this experiment, please don't forget to share a comment, and I'm going to be responding. Thank you once again as I walk you through the class. So this is the diagram you are meant to set up. This is what I figured out from the white paper given, and you need to connect it by knowing what the components of this electricity are, their symbols. I'm sure you should have known that before coming here. And you are going to read the instruction. This is the instruction you have to read carefully. And this is the table of value at just the bottom corner, bottom right corner. That table of value you all to just do the experiment and put in the current. Remember, this is not an expo, it is just a guide. This is the constant time wire, and this wire has a given resistance, and while this is an ammeter, as you can see the A there represents ammeter. This is a cell. This is the one I'm using, and each of these cells represents 1.5 volts. This is a key. This is a key, and this one is called key plug. Sometimes we call it a key, or sometimes we call it a switch. It is used for opening and closing of the circuit terminals. All these you are seeing here, they are the connecting wires. And this is a clip. This is the one they call crocodile clip. If you look at the mouth looks like that of a crocodile. That is why we call it crocodile clip. And this is a 2 ohm resistor. And resistor, it comes in different designs and shapes. Then we have this one. This is a potentiometer. This is a potentiometer. This is a meter rule, and I would like to use this in place of the meter rule, because with this now you have the wire, the constant time wire. The one I'm going to use is this one, this tiny one, and it is stretched along this wire. I'm going to use this one for this experiment. Now I am going to show you how the connection is made, and I want you to take your note and pay attention as we go take it. So, having known the materials or the apparatus you are given, you can now do the connection. Like I said before, this is the constant time wire. I have already stretched it along to make 100-meter length. So my battery has been recorded about 2.9 volts. I'm going to call that my EMF. My EMF is 2.9 volts. So I'm going to connect the circuit as shown in the diagram. You see the diagram on the screen for you, which I've seen and read. So I'm going to start from the cell. I'm going to start from the cell. This is the cell. I don't need voltmeter, so voltmeter has done its job. From the cell, I will go to the key. You see the way I'm connecting it from the cell to the key. From the key, I will go to the resistance resistor, 2 ohms resistor. I will go to ammeter. I am not noting the positive and negative terminals. I will find out, I will show you later. But because if I don't note the direction of the positive, if I don't know whether this side is positive or this side, it will make me, after reading, this may go this way, and I'll have to change the terminals. From the ammeter, I will go back to the battery. From here, I'll come back to the battery. So this is the first phase of my connection. Then to check if my connection is true, is positive, I'll close my key. It's positive. The terminals, they are positive. And I have to measure the current recorded by the ampere, by the ammeter. At this point is 0.6. Okay, you need to avoid parallax error. Let me call it 0.62 ampere. So these are my recordings. Then we keep moving. So I have to open the key to avoid wasting the energy of my battery, to avoid discharge, excessive discharge of my battery. Then the next thing I have to do is to connect this constant time wire along this length. But the question should be, having known this, where am I going to connect? I am sure one terminal connected it to this constant time wire, which is along this length. But I have to ensure that my constant time wire is well stretched, is sound. I need to stretch it well. Yes, I need to stretch it very well so that it will be timed, stretched, so that the length will be effective. So I connect at this point. So I'm going to use my crocodile clip. I'm going to use my crocodile clip and connect to the other length or the other terminal of the resistor, so that it can be parallel, as if I'm connecting this in parallel with I'm connecting this in parallel with the resistor. Of course, that is in parallel. I need to tighten all these terminals to ensure that my connection is good enough. Now, we are going to start this experiment, but before that, you need to know the theory that guides this. Normally, the increment in length of a wire leads to the decrease or the reduction in the current. The current will reduce. As the length of wire is increasing, that means more atoms are involved. And because more atoms are involved, the potential difference across them, we find it more difficult to push the electrons around them. And as a result of that, the current will be reduced. So that is the simple thing. But the potential difference across 1 unit length of a wire is directly proportional to the length of the wire. So all these are going to be put in place. Ohm's law is fully obeyed in this our experiment. And remember, the resistance of a wire differentiates from wire to wire. So we are using constant time wire so that everybody who is doing this experiment will have the same outcome. Now I'm going to remember. So the current I recorded, which was 0.62 ampere, is the current flowing in the circuit. The first current I recorded is the one that is flowing in the circuit. Now I have not closed this part of the circuit. So everything that happens within here is the current. This is the current flowing through the circuit. You know, current flows all parts. Let me remove this one for you to see what I'm saying. Current flows through this wire, this way. So this is here to record the current passing through it. So the current flowing through this wire has been recorded by this ammeter as 0.62. So I am going to connect the potentiometer. I'm going to put the clip. I'm going to put my crocodile clip across the length according to the question. The first thing we are going to do is I'm going to put this in at the 90th centimeter and see what will happen to the current that we are going to have. So 90, I'm reading from here. This is 0 and 0. I am locating 90 along this path. This is my 90. As you can see from the experiment just conducted, or I'm conducting, you will realize that when I put it in 90, I had a given current which I recorded. When I put it in 80, the current increased a little, very small increment. So that is why we are using 0.1 ampere. When you put it in 70, it increased a little. When you put in 60, it increased a little, as you are seeing on the table of value. That is the essence of the experiment, that the current will be increasing for a reduction in length. Thank you. I am going to plot the graph. The graph is plotting L against L inverse. So that is what I'm going to do. In the next video, just check the next video, you'll see the graph. Thank you.